I'm going to show how we build this entire application, including the front end here on Modal. There we go. Now that's the girl with the pearl earring. The pearl earring is more of a pearl collar, but we've got that nice blue head wrap, the serious look of Vermeer's girl with the painted earring, but transmitted onto this dog, which is just delightful. This is where we're going. This is what we're going to get by the end of this webinar. I'm going to show you how to get to that in a single Python file. So for this webinar, I wanted to go through one of my favorite examples of from the Modal doc, from our collection of examples. And it's one of my favorites because it was one of the first things that I did with Modal back in 2022. I discovered Modal while searching around for a good way to deploy my machine learning applications. I've been working on training models and fine-tuning models, and when it came time, and it was had all these great tools for my training process and had a great stack for that. But then when it came time to deploy, things were just so painful. It was try and make the model small enough that it could run on AWS Lambda, or experience the pain of running auto scaling GPU services on clouds. And so I found Modal, and it solved all of those problems, made all that really easy. And so I immediately used it to, when A100 GPUs were added to the platform, immediately went and used it to do some fine-tuning on stable diffusion models, which this was just before ChatGPT, so back when stable diffusion models were the absolute hottest thing. So let me show you the application that we're going to just do a quick demo of what the application we're going to see how to run on Modal. So it's this Dream Booth application. So the idea with Dream Booth is that you teach a new proper noun to a diffusion model, to an image generation model. So this was around the time in 2022 when my roommate adopted a new puppy named QWERTY. And QWERTY was this tiny little adorable golden retriever. And I wanted to be able to generate pictures of QWERTY, doing all kinds of interesting stuff. So if you have any ideas for generations that we should try of what's a good fun prompt for an image generation model, I'm going to try to put her in a video game. Elder Scrolls Morrowind, a nice classic video game. Let's see if we can dream that. So this generates pictures not just of any golden retriever, not just of any puppy, but pictures of this particular puppy. You can also use it to generate pictures of yourself, your friends. The kind of core idea here is that you take a bunch of images that you've labeled with that proper noun, and then you pass them. You train the model on pairs of description, that proper noun and the image. And turns out the surprising thing about this Dream Booth results and the later low rank adaptation fine-tuning results was just how little data you need in order to run something like this, in order to in order to fine-tune a model. Not thousands of examples, tens of thousands, or the kinds of numbers that you need in training a model from scratch, which you run into the millions or billions of examples, but just 3 or 4. And there we go. The result came back. Look at that. Morrowind is a late 90s, early 2000s computer game, kind of a fantasy game in the same series as Skyrim, if you've heard of that. So there we have QWERTY in her little leather armor. And you can see this, the prompt is golden retriever, but QWERTY is what's called an English cream golden retriever. So she has this kind of white fur instead of gold fur. And that's something that the model has learned is a feature of QWERTY from the training. So yeah. Let's see. Maybe let's try one more. This is a kind of a fun one. Painting of QWERTY the golden retriever with a pearl earring by Vermeer. Let's see. Running should be a little bit faster than 60 seconds. That's a pretty slow inference, even though we're running a pretty beefy stable diffusion model. There we go. Okay, must have had to load from scratch. All right, so that's QWERTY the golden retriever in a Vermeer painting. Let's re-roll that one, see if we can't get a better example. It wasn't bad, but we could maybe do better. And yeah, feel free. There's a chat window in the Crowdcast if you wanted to suggest something that we might try here. There we go. That one looked a little bit more like her. It's a little bit of the more cream colored fur. I'm going to show how we build this entire application, including the front end, here on Modal. There we go. Now that's the girl with the pearl earring. I guess you don't see a lot of images of dogs with pearl earrings in the training set. So the pearl earring is more of a pearl collar in this example, but we've got that nice blue head wrap and yeah, the serious look of Vermeer's girl with the painted earring, but transmitted onto this dog, which is just delightful. So this is where we're going. This is what we're going to get by the end of this webinar. I'm going to show you how to get to that in like a single Python file. So let me drop that and switch over to my VS Code here. So you should see now my VS Code terminal at the bottom, code at the top. So this here is actually the logs from that app that I was just running. You can see this post/run/predict. That was when I was clicking the button to generate new examples. This was showing up here. I was just running like a little development version of that app, not like fully deployed, just like kind of like one that I can like play around with in the terminal and in my editor. So let me shut that app down, clear it out, and now make a little bit more space to show code since that's the main thing that we're going to be seeing, and scroll all the way up here. So the modal examples kind of have this interesting structure. We have these, so this is a GitHub repo, the modal examples GitHub repo, and in that repo, we have these Python files, and in them is like intermixed all this like kind of explanation about the example as these comments, and they're markdown formatted comments. Just dropped a link to the example, that the same Python file in the chat in the webinar. So this format here it's meant to be readable in your when you're in your terminal or in your editor rather, so that you can look at this and read this. It's also turned into these nice kind of rendered examples. That's what I linked all the way back when at the announcement of the webinar at the beginning of the chat. I'll just link it again here. That's our like documentation. We render that as this nice web page. So it's a little bit easier maybe if you just want to read the text and don't want to run the code to go there. But we'll kind of do both here. So this example kind of walks you through in detail how to like run what all of the components are. So some of the things that we're going to do in order to set this up, that front end that I was doing was a library called Gradio from Hugging Face that lets you make simple user interfaces in Python without having to write any JavaScript, which is nice for kind of like making demos of your ML apps or making like a simple internal page. Then the other things we're going to do, we're going to accelerate our code with GPUs. We're going to use distributed volumes from Modal. So like kind of like a file system that you can access from any Modal instance, like without, with that's much simpler to use than like saving and loading things from S3 with like Bodo or what have you. And then we're going to serve it as a web endpoint. So I was in my browser, and I don't know if you were looking at my search bar, the URL bar, but it was like that was an actual URL. It wasn't localhost, no localhost here. So we're going to serve it as a web endpoint and deploy it as well as a web endpoint. So we're going to do all of that, and because of the like Python forward and the like very powerful and flexible interfaces that Modal provides, we actually do this all in one single Python file. So this Python file that I've linked, which is like, I guess it looks like it's 500 lines. It's about like 200 or 300 lines of text. But we can put it in this like relatively compact Python file. It has the infrastructure definitions, it has all the code, and we're going to have our fine tuning and our deployment all in this single file. So let's walk through what's in that and what makes that happen. So at the top here, we've got some of our basic imports. We've got some like Python standard library things. We've got Modal, and we've got Fast API, which is the web framework that we're going to use for running like for like serving our apps. So Fast API is kind of like probably the best Python serving framework to use, like web serving framework to use with Modal. It's like async Python is like, there are other frameworks like Flask that you may be familiar with, but they a lot of them kind of predate the time of async Python, and async is really, really useful for making something like Python scale up and like actually be able to handle a big web service It's like it allows you to handle requests concurrently with each other, even though you only have like a single processor or single thread. It's like the same thing that gets used for full stack JavaScript web serving, actually. The same like basic pattern, single threaded concurrent approach is like the core thing with Fast API. So we'll use it here, and that fits super well with Modal's like async centric and like auto scaling setup. So we'll be using Fast API for our serving. One thing you won't see is importing up here is like there's no import diffusers. So like Hugging Face libraries aren't getting imported up here. I'm not importing Torch. None of that is happening up here because this Python code that's in the global scope is going to get run locally when I'm setting up my app. So when I'm like setting this thing up to run on Modal, I run code locally to like configure it and then send it off to Modal to be run. And I don't want to have to install those packages locally. Like some of them require a GPU or they behave differently when there's a GPU available and not. And they're like, heavyweight. But the Python environment that I'm going to be running this in just is like regular old Python and then pip install Modal. And that's all I need to be able to use this, which is great. Like if you're in a CI environment, you want to be able to run this in GitHub Actions or whatever. Like all you need is basic Python and then pip install Modal, and you don't need to like recreate your development environment in the CI/CD environment. And both of those need to like tightly reflect what's going on in production. You avoid that by doing this sort of more cloud native development style with Modal. So we'll see a little bit more detail on that. I just want to call that out because people, this is our imports at the top, and it's like we're done with our imports already. But we'll see that we import them instead inside of Modal, inside of the stuff that runs in the cloud. So speaking of packages, we do need to like install these packages. We do need to like get like all these things that we need, transformers and diffusers and all that. The way that works in Modal is we build up an image. The term comes from like containers, like Docker style containerization. So we need an image, which is like the state of the file system when your app spins up. Basically, what an image is. And so anything that you can write to a file system and that like and persist it, and it's the same every time you need to like serve an app or run training, that's stuff that can go in the image. So the things that are like I want to call out here is we've got Debian Slim, that's like our core like Linux image. That's where you start from. So we're saying start with like regular old Linux. You can specify a Python version if you want. If you don't, you'll just get the same Python version that you're running locally in your Modal container. So I specified this one just to make sure that this example is nice and stable, no matter who runs it, no matter which Python version they're using. And then and then we can kind of like chain methods on top of it. So this pip install method here that I'm highlighting is like we're chaining. We started with an image called Debian Slim, this like base Linux image, and then we chained a method on it, and we said take that image and install some Python packages on it. That's what this .pip install does. And then we pass a list of Python packages, and it looks a lot like what you would put in a requirements.txt file. And you can also pass a requirements.txt file. That's totally fine. Like we also support that. There's a bunch of other ways to install things. You can use micromamba. You can just write your own commands if you want. But kind of the approach that Modal takes is to try and put as much as possible in code where you can kind of like manipulate it programmatically. Like I could construct these in code, for example, and pass them to .pip install instead of like writing them to a file. To like give you that flexibility, and also to try and provide some like higher level things than just Docker file commands, which is kind of what this all in the end compiles down into. If you're familiar with containers, containerization and Docker, we tried like keep it at a higher level that's closer to like where you want to express the things that you care about, like which versions your packages have, without having to worry about some of the like foot guns and gotchas of building Docker images. So that's here. We've got a good number of components that we're bringing in here. Gradio, I already mentioned. Transformers. Accelerate is going to be our training framework. That's also from Hugging Face. And I think we'll use Weights and Biases, the machine learning experiment tracking platform where I used to work as our to like track our fine tuning job. Maybe actually like backing up a little bit. Why am I like spending so much time talking about the imports, talking about the image? Like where's the ML? Where's the AI and the neural network? Part of what makes deploying machine learning hard and working with neural networks hard is the complexity of the environment setup. It's always an absolutely tremendous pain in the ass. to get any of these things working. So I want to focus on the tools that Modal gives you for setting up those environments, for creating them repeatably, for controlling them. And I want to do that, like, I want to leave you empowered to be able to use it. So I want to go through all of these pieces because it turns out that when you're like, oh, I want to get this new thing running, I want to run it on 8 GPUs. Like the hard part often ends up being this like environment, this like fairly prosaic environment setup stuff. So in addition to like pip installing things, we can add things like system packages with like Linux system packages with apps like apt. So you can apt install packages like here we're bringing in Git, and then you can also just like run whatever command line commands you want to change the state of the file system and set up the image. So in this case, we're pulling in a specific commit of the diffusers repository from Hugging Face and like pip installing it, and that's just easiest to express as like a sequence of like command line commands. And this gives us lots of control. So we can do things like this fetch depth equals 1 to make sure we don't grab like the entire history of the repository. So yeah, so sometimes like with these like more complex kind of like researchy kind of brittle ML packages, you often need this level of control to get something working. And so like this is something that's offered by Modal. The other thing I want to call out about this is I'm still doing that method chaining here. So I'm taking that image that we already defined up above, right, which is this modal image with like the packages like pip installed into it, and then I'm saying, oh, take that thing and then run apt install git and then run these commands. And I'm like building it up kind of layer by layer. And that's kind of the way these container images work. It's like a sequence of operations that build on top of each other, that layer up until the final, the final state of the file system at the point that the application starts running. So this mapped onto this method chaining style from Python that you'll be familiar with if you've used like pandas is one example of a library that really leans into that style. All right, we got some configuration stuff. This isn't particularly interesting. I think one thing I'd call out is like these data classes are kind of like a lightweight way to have like types easy to serialize and pass around like information configuration. So that's which we like where you would maybe in another case you might like if things get more complex, you might need to reach for something like Pydantic if you're familiar with that library for like serialization and typing of like things that you're passing around a Python web application. But in this case, it's relatively simple. We have just a couple of strings, so it's easy to just keep it as a data class. And great. Now, one thing that's like, so what I've described so far is like coming from Modal with pip install, apt install, and run commands. Like that's fairly standard container stuff. Nothing too special for Modal. Like we have optimizations to try and make those things fast, so it's really fast to boot up a container, but nothing particularly special. This is kind of a fun bit of what Modal's capable of. This run function method that runs Python code to set up what your image is. So it's like not bash commands, not like these like specific ways to get a hold of libraries, but just regular old Python code. You can pass that in and say run this while setting up my environment. The reason why that's helpful is like sometimes even the flexibility of running things on the command line is not enough. Like you want to like reach into the actual library that you're using and do some stuff like while you're setting up the image. So in this case, we're using Hugging Faces from pre-trained like method on their pipelines to get a hold of everything that we're going to need when we do our fine tuning, and actually also when we do our serving, we're going to need those base weights. And it's just there's ways to do this from the command line. You totally could do it as bash commands, but it's like there's like an elegant simplicity to like using the actual Python that you're going to be that like where this also like the same code paths that are going to be executed when you actually need to like load stuff at inference time. So there's some power, and also like we can do things like pull in that config data class, and so we don't need to like repeat stuff, or we don't need to like pass things across a boundary between like Python and Bash, or like you send them over a network if we don't have to. And so that's kind of the power of this like run function ends up getting used a lot, especially in ML, where there's like lots of things are expressed as Python. So I might actually, let's see, do I want to kick this off? Let me just show you what like so that you have a little bit clearer sense of like what this code, all this code I'm showing you, like what happens with it. I'm gonna do what you do with one of these like modal scripts is there's a couple of modal commands you can use them with. The one for fine tuning in this case is modal run. So modal run and then point it at the file, which is this dreambooth app.py file. Let me run that. There we go. So what's happening is Modal is like making sure that all those images I described already exist. It doesn't need to build them because I've already created them in the past. If you run this same uh, like command right now, it'll build from scratch. It'll do that run function. It'll like load the model. All that stuff will happen. And now, in addition to setting all this stuff up, at the bottom of this file, I set it up to run training. So that we're starting to run training there. Let me drop to the bottom. That's the app.local entry point here. This app.local entry point says, what should I do when you call modal run pointed at this file? And it says like call this train function and run it on modal, and like set up the training data and then run training. So we were about up here at download model. Just wanted to run that so you can kind of see like, okay, so this Python file is going to be run using this modal run command. That's where this all is going. Cool. All right, so we've talked a little bit about like how we set up the environment, and I emphasize it's like setting up the state of the file system at the time that your app starts. And so it's a lot of stuff that you kind of need to have like predefined before you run anything. But what about like file system? What about like things that you want to have on disk for when your model is serving, but that you don't have before you start running your application? So for that, we have modal volumes. So like a modal volume is basically it's a distributed file system. It's like a file system, but you can access it from you can attach it to any modal worker, like any modal function that's running, and say like, let me be able to read from this and write to it. It's kind of designed with ML and data intensive applications in mind. So it's like oriented to writing large amounts a very small number of times and then like reading them many times. So the write once, read many pattern. It's oriented to like running, like if you have an OLAP database, or if you want, in this case, to save like machine learning weights, right? You like, they're kind of big. They're like definitely at least megabytes for like, a low rank adapter, maybe gigabytes for base models. And then like you write them one time, but then you read them many, many times. So that's the thing that these are best at. You can they're a generic file system. You can like use them for all kinds of shenanigans. But that's kind of what they'll be most like performant and ergonomic for. This is saying I'm going to be using this Dreamboost fine tuning volume in this application. And if I haven't created it before, please create it. So you can actually reuse these volumes. You might make like one script where you like download a model into a volume that has creative missing equals true because that like creates that volume and like writes to it. And then in an application that reads it, you would get rid of this creative missing parameter and you would say like, okay, this application only runs if this thing already exists. So don't create if it's missing, just like error out because I'm just a reader, not a writer. But yeah, so that's what these like distributed file system volumes are for. And one thing we don't use them for in this example is for storing data. You absolutely can like put arrow files or whatever on there. For this example, because it's this Dreamboost fine tuning, this low rank adaptation, you don't actually need that much data, and so we actually just like load it live from like a URL whenever whenever we run training. I think like 3 examples, 16 examples, like that's all you need, and it's just simpler. Just like pass that around. Like you can put it on Google Drive, you can put it on Imgur, you can put it on like whatever, and pull it in. And so that's what we do here. But you could also like if you have a bigger data set, you can use volume. You could store on a Hugging Face data set and pull it down from there. So that's our data loading code, and now time for fine tuning. Go into a little bit of like kind of more detail about how the fine tuning works here, and like kind of explaining what the fine tuning is, linking to some useful papers. One thing actually, I'll just change this while we're here. I'm gonna turn on weights and biases logging. It's not on by default in this example because we don't want you to have to create an account. But yeah, weights and biases, machine learning experiment management platform that allows you to like kind of track what's going on when you're doing a fine tuning job. So I ran this fine tuning job, like the one that I triggered a couple minutes ago, that's like with modal run, and like you can see this like all this stuff got logged to the terminal, and especially like in this like zoomed in cramped terminal, it's like pretty hard to read what's going on here. Like what's the lock doing? What's the learning rate doing? Like, and also like if I close this terminal, it's going to be like gone forever. So you want to be able to log this stuff just because machine learning experiments, you tend to actually learn a ton from machine learning experiments. You learn about the data, you learn about the models. Let me show you actually a quick example of like something you can learn from tracking your experiment. This is the like panel view so that you can see what happened in a way biases run. Um, like looking at this like loss over time thing, like loss at the beginning was high, it kind of got lower over time. I think if I were to maybe edit this panel and add some smoothing, let's ignore outliers. Where's the smoothing button? Oh yeah, there it is. You know, back in my day, the smoothing button was elsewhere, but you know, okay, yeah. So we can see like what happened to the loss over time. Like kind of not obvious what's happening. Looks like it's kind of flat. It's a little bit harder to interpret losses in fine tuning runs, especially these like super low data ones. But like the thing that's super clear is we look, oh man, wait, all of my images are just black. So like these are supposed to be output images from the model. If I look at them, they're all just empty. And that is not like a bug in the logging software. Turns out there was a numerical instability problem. So if you don't actually like look at the inputs and outputs of your model, it's like pretty easy to fool yourself into thinking that something is working well during training, and then it turns out you've been wasting your time. So there was a numerical instability issue, and I needed to bring in a different like patched version of the variational autoencoder. Um, and oh yeah, question from Colton coming in. When we run this, do we need to create a slash image directory locally with the training images? So great question. Let me as I am going to answer that question. Let me just quickly kick off another training run now that I've turned on weight biases logging. And then that'll be running in the bottom there, and now I'll answer your question. So that's this line here. Um, line 164. That so it looks like you would need this slash image like at the root of your file system, that you would have to add that, and you don't, because this code only runs on Modal's remote containers. Like it doesn't run locally. So the Python code in the global scope of this file runs locally, and then anything that you do inside of a local entry point runs locally. Let me show you that local entry point. I think I mentioned this earlier, but this local entry point also runs locally. So we run everything in the global scope, and then we run this. So the global scope usually kind of like defines your infrastructure, defines your application, maybe does some configuration stuff, and then like you define all the functions you want to run, but you don't like we don't reach inside those functions and run them. So that load data function is an example that we define it, we like see its types, and like we create that function, but we don't execute it. So you don't need that like slash image path. Instead, only this stuff gets run. So like this train config here, this guy, that's one of our data classes that I talked about previously. This does get run, and that is where the data comes from. It's this collection of URLs for data, and that is available. That does need to be around locally. And if you look in my terminal in the bottom right there, you can see that instance example urls.txt is in the same folder as this Dreambooth app example. So this is something you'll see in a lot of the modal examples. We use path dunder file like this. Dunder file is like one of those Python magics like dunder name and dunder main that says like wherever this file is located. So like path to this file wherever it is on the machine, and then we express like instance example url.txt is like relative to this file. That's just one pattern for providing the data. There's any number of different ways. Like you could hard code that like a list of URLs. That's not that hard. Like you could keep it inside the example. You could point at a Hugging Face data set. You could point at you could save files to a volume and use the volume to store the data. The key thing is just you need something that describes like where to get the data for this like when the function is running remotely on Modal. Okay, so hopefully that answers Colton's question. Let's check back in on that training run that I kicked off. Okay, yeah. The training run with W and B runs a little bit slower because as we're going, we generate some images with like a special validation prompt so that we can track how our model is doing during training. So looks like, let's see, if I scroll up, I can find the W and B URL, which would be great because I can share how our training is progressing. Let me do that.
All right. So, what do we get from using weights and biases? Like, why is that important for this? We can see like on every couple of epochs, we ran our um, a prompt through our model to see how it's doing. And we can see at the start when we ask for a photo of Cordy the Golden Retriever, we get like a generic looking Golden Retriever, right? Like, this looks like this is a Golden Retriever from Central Casting, and then and so what we did is like every couple of steps this got logged, and we can see after a few steps already it's now a Golden Retriever puppy instead of an adult Golden Retriever, though it's still a Golden Retriever rather than an English cream. And let's keep going. Let's jump 2 epochs ahead. Now you can see it's like starting to pick up. Actually, you'd have to look at some of the data to see this, but some of these this like collar thing is from one of the example images. You can see it's a puppy, and the fur color is getting lighter and lighter. At the end, this is like probably the best example from our validation set of like looking like the actual input data. Great, and we also get a test here at the end. Yeah, that's a good one too. Okay, so we've run our training run using Modal and confirmed that it worked with weights and biases. So what was that training function that we ran? That's defined here. So what we do is we like write a Python function to do that training, and then we wrap it in this decorator here, this app.function decorator. And this decorator is what like modalizes or like takes a function and puts it up on Modal. There's a couple of pieces like that show up pretty frequently that, or well, yeah, let me go through the things that we specifically talked about. So we talked about the container image. Like, what does the file system look like when this function starts running? Well, it's this image that we defined, right? Which we did by like chaining all those methods together. We said we needed this volume here. So we are going to mount at a local on this machine at /model. We're going to mount that file system, and so that's where we're going to save our like fine-tuned model. We set a timeout. How many seconds do we want this function to run for? This is important in any distributed system just because it's easy for things to fail and then just like sit around consuming resources and not fully crash. So we set that timeout at 30 minutes. The maximum timeout on Modal is 24 hours. So you can run for up to 24 hours. If you're running a longer job, you can kind of set it to restart after 24 hours. So like save the weights to the volume. After 24 hours, the function like times out, finishes, you like do some cleanup, and then you start another one to now run like a 48-hour or 72-hour training run. Another thing that you can add at this decorator stage are secrets. What are the like API keys, like the WAN-B API key or the Hugging Face API key for downloading models? What like secret information does this function need access to? And of course, you can attach GPUs. So you can add NVIDIA GPUs. Anything from like a T4 all the way up to 8 H100s can be added via this decorator here. So you can change that. You could change it to like run on an H100 and then just modal run, and the same function will now run on different hardware. And the details of this are not particularly that interesting. I guess maybe one thing I would call out is you don't have to like directly run Python code inside of a function on Modal. In fact, a lot of the time you end up running like command line scripts from Python. So using the sub process part of the standard library to like run something like accelerate here. Accelerate launch is like something you run as a sub process. And so it's like a command line tool, but you can use it on Modal because you can call command line tools from Python. And that's kind of the pattern shown here. The details of the configuration aren't like, they aren't particularly interesting unless you're fine tuning your own SDXL models. There's some documentation of them, of all this stuff in the code example if you're interested. Then now it's time to serve. So let's actually serve this application. So as I said, you can modal run stuff, and that takes the stuff in your local entry point and executes it. You can pass command line flags if you want. In this case, so that's modal run. The other two things you can do are modal serve and modal deploy. So modal serve is what I did to set up that example like app that we looked at the beginning. Let me copy that URL there and put it in my browser, and I'm going to open up now that thing that's running. And you can see, if you look in my terminal there, you can see that there's something loading. So like in a separate window, I just hit it with my browser, and now it's spinning up. So let me share that with you. So this is what was just served with Modal, this application. And you can see up here, there's that URL. I copied this URL from my terminal. So, and it's running on modal.run, so not localhost. And let's do QWERTY, the golden retriever, is a knight fighting a dragon, and dream it. Okay. And now let's switch back and show what that looks like at the same time in VS Code. There we go. So we can see, like, when you do modal serve, you're setting up like a little development server, and so you get all the logs directly in your terminal. So we have this get 200 OK, get theme.css. That's me hitting the application, and I get from my browser, and I get the logs. And now we see like why that first run takes a little bit longer. Why is that? Oh, it's because I need to load the model pipeline the first time that the thing runs. So there's kind of two components in this. I think I'm going to skip over how we do the inference for a second and just focus on how we set up the Fast API app, because that's like a little bit more complex and a little bit more interesting. So the way that you serve, that you like wrap your functions on Modal in like an API, is you take a Fast API app. So this is the Fast API class from the Fast API library. It creates this web app. This is this implements something called the ASGI protocol, the asynchronous server gateway interface protocol, that allows you to take like one web server and kind of like put it inside of another. So like WSGI is what Flask implements. It's a similar kind of allows you to like mix and match web servers. And in this case, we have ASGI from Fast API. And the way that you like serve something that is an ASGI app, which actually also includes the new Fast HTML library or framework from Answer.ai, Jeremy Howard's company. The way you take something that speaks ASCII and serve it on Modal is you just make a Python function that returns that object. So this, if we get down to the very bottom of this Fast API app function, it gets returned at the end here after passing through a little utility from Gradio. This returns like a Fast API app, an ASCII app. So we take a Python function that does that, and then we wrap it in modal.ascii app, and that tells like the Modal client and Modal server that this is not this is not just any Python function. This is a Python function that speaks ASCII, or the object it returns speaks ASCII. And then you can add the same, like you decorate that with the same sort of information that you would decorate any other Python function you want to serve on Modal. So like you can say, what does the container image look like? You can set how many replicas you want to run. You can this mounts the CSS that's available locally, so that like we have the CSS for that styling of that Gradio app. So this decorator here gets applied outside of this one that says, oh, this is an ASCII app, and says like, this is something that you should serve as a web app. Other modal functions aren't necessarily available over the internet, right? Like you wouldn't want to always make every Python function you write available over the internet, because then other people could use them too. But if you want that to be the case, then you add these decorators like Modal ASCII app, Modal Web Endpoint, Mobile WSGI app, or Modal Web Server, which allows you to just serve anything, like anything that can listen on a port can run under Modal Web Server. So maybe you wrote your own web server, or you're using some like special internal tool that does web serving. Doesn't speak ASCII, doesn't speak WSGI. It's its own thing. It's a Rust based like web framework that does stuff super fast. As long as it listens on a port, you can put it on. You can do the same basic pattern of like decorating a Python function and then serving it with Modal. Great. So what does this thing do? I'll just quickly say, how do we do the model inference? We write another Python function, actually in this case, a Python class for our inference, and we set that up as like something that now our fast API app can call. So this .remote here is a feature that modal functions have that says this function that I defined above, don't run it here, don't run it locally, run it remotely. And the nice thing about that is that means that my fast API app actually doesn't need a GPU. And so I can independently scale the GPU-based component and the CPU and like web serving-based component, because they have very different scaling needs. And so that's kind of like maybe one of the core pitches of Modal is like your different components of your like data-intensive ML application are going to have different scaling behaviors, different infrastructure needs, and like infrastructure from whether it's a GPU, whether it's like available over the public internet, and so has like networking and like a domain name, whether like which Python packages are available. These are all things that like your application, different components of your application are going to have different needs, and they're going to be complex. And it's really nice to be able to express that inside of your Python code alongside the definition of the application logic, because it's like with ML and data intensive applications, that logic is actually kind of intertwined with the infrastructure itself. So they're separated, like it's applied via decorators, but it's like by putting it all in Python and not like separating out configuration, you have like greater flexibility and greater integration when you need it. Actually, let me do one more thing while we're still in VS Code. Something that people worry about with doing cloud native development, like, wait, I just defined a Python function that only runs remotely. What happens? What do I do when I'm debugging? And I definitely experienced that with other like cloud development providers, other infrastructure providers. Like before finding Modal, it was like, oh man, it's such a pain. I like put a semicolon in the wrong place. I mistype a variable name, and it takes me half an hour for SageMaker to like boot up, run, and then choke on some like obvious issue. Modal's designed to like really quickly boot up, and then also give the ability to interact with the infrastructure you're using. And so Modal shell is one of my favorite commands for this. Like, what if I wanted to see, like, I talked about like how the container image and the volume kind of like set up the state of the file system. What if I want to just like explore that and see what it looks like? That can be challenging in other environments, but with Modal shell, you can actually just get on there, and I think I should have a GPU. Yeah, sorry, kind of like, let me zoom out real quick just to show the NVIDIA SMI output. So I'm now on, it has the same infrastructure that the actual function has. It has an A100, 40 gigabytes on there. And I can see it with NVIDIA SMI, and it's just a regular old shell that I have here. So I can do anything that I could otherwise do in a shell. Like I can look at my volumes. What did I call the volume? Oh yeah, model was the volume that I loaded, and I can see here like what got loaded. Like is everything, like the UNet is here, the variational autoencoder is here. I can inspect those. If there's a bug, I can look at those things. And also the code is available. Like what code is running? Well, I cloned one of the things I did was I like cloned the Dreambooth code, and like I have that Dreambooth app.py available, and I can see Dreambooth app.py. This is that same code I was showing you before, but this is it on the remote worker. It's available on the remote worker because the remote is also running like that Python code, runs everything in the global scope, and then runs the thing you asked it to run, like the training function. So that's so I can see it and inspect it and be like, wait, what is the code running there? There's also ways to do that from the UI, like the Modal dashboard, which I haven't even looked at this whole time. Just been focusing on the code and the application. We also have a UI and a command line interface for looking at these things. If you want to like modal container exec, modal container stop, like interact with a running container, turn it off, or if you want to like look at the files inside of a volume that you've created. That's all doable. And yeah, so the last thing I'll say is, this was running end to end. The title, I think, running end to end ML applications on Modal. We haven't deployed yet, so let's go ahead and do that. Like I was serving, but that was like kind of this like local development thing. I like or like the equivalent of local development where you're just like kind of playing around with things and it goes away when you're done. If I were to go back to my browser now that I've turned that modal serve off, like it's gone. I'm not able to interact with it anymore. But let me do modal deploy to actually create a long running or like permanent version of that application. So it looks pretty similar to what happened when we did modal serve. But the difference, if I'm making my window a little bit wider, let me rerun it to make sure. There we go. So this URL here is where that Fast API app is being served from. You can see it's called Fast API app. It like inherits a name from the Python function by default. That's this guy here. And the only difference is like when you're doing in development mode, there's a -dev at the end, so it's a different URL. And then like this one is now available like in general. You can come back like a week later, it should still be up. Maybe I've deployed a new version, so it might not be exactly the same. That application, until I delete it, turn it off, that's available permanently. And you can still do things like examine the code that's present there and check on it. Yeah, so great question from Colton. For project cleanup is the only thing with a recurring cost, the deployment itself and the volume storage. So yeah, I can't believe I haven't mentioned this. The setup with Modal is that this is all serverless. When I deployed that, let me take a look. Let me scroll down and show you up here. The default behavior of a modal function is that if nobody's asking for it to run, if there are no inputs available, it shuts down. It waits about 10, 20 minutes after 10 minutes? No, 5 minutes after the last time, by default, after the last time it got an input to spin down. So that's actually controlled with something called the container idle timeout here, which is like how long after I get an input should I keep this thing up? So you get the permanency of having a deployed application, but without the cost of needing to like pay to keep the thing up all the time. So like GPUs, for example, are like pretty expensive, like $1 an hour on to run an A10G, which is what the inference GPU is in this example. But that's still $1 an hour, and maybe like this is like a demo that you're using, like to show a training run to your team and be like, oh, check out this new training run. Let me know if you notice any issues with the new model. And you don't want to be paying $20 a day to keep that thing up. So by setting like by default, by hosting it on Modal with our serverless model, you don't actually have to pay anything to keep it up. You can turn on keep warm. Keep warm equals 1. This says, oh, I actually do want to keep some containers alive all the time, even if there are no inputs. And that can be useful, like as your application starts to scale up, maybe you know that you always have enough traffic for like one replica. Like there's always some people hitting this, but then every once in a while it like trends on Hacker News, or gets posted on Hacker News, trends on Twitter, or whatever. And all of a sudden you need 10 or 100 replicas, and Modal will automatically scale those up, handle the traffic, and then scale them back down. But that's a whole nother webinar. I showed a lot of that in the previous webinar, which is available on YouTube if you want, on running an LLM inference server, that auto scaling. Then you do have to pay to like keep one instance warm, but you kind of need one of those around all the time to handle your traffic. And then we like scale up to handle traffic and scale back down when we're done, when the traffic is done. And so you don't have to pay for all of the infrastructure that you need. That's an important part of what like makes Modal like economical and not just like a really good developer experience, which is maybe what I've been focusing on kind of like the developer experience in my demo. It's also that it like means that you don't have to pay for a GPU 24 hours a day just to be able to run a stable diffusion model a few times a day. And so for cleanup, there should be nothing that you're getting charged for if you're not getting any traffic. The volume storage right now is free. I think we might eventually start charging kind of like S3 type prices for volumes, just like as the like scale that we're operating at increases, and as more people start to be like, oh, sick, free storage, let me just store like 10 petabytes there. So great question, Colton. Thank you. Yeah, so that's deployed now. You can hit it. You can check it out at that link. You can generate your own Cordy the Golden Retriever images. I'm closing out now. I do have to head out very shortly, but let me go back to that stream booth and show an inference. Cordy the Golden Retriever is a knight fighting a dragon. Well, she's not fighting a dragon in this image, but that's kind of how ML is. Doesn't work every single time, but she does. She is wearing her plate armor. Yeah, so that's a end-to-end ML application, like getting a hold of data from somewhere on the internet, then saving those weights, and then serving them in a simple UI, all in Python, all on Modal. So hopefully this shows you the patterns that you need for deploying your own application. It's also kind of fun to make these for your own pet. I was giving them out as gifts to people. I would make one for their pet and then share it with them. So it's a fun little app, and the patterns that you would need to serve an auto-scaling machine learning app as like a distributed web Python application on Modal. So if you do end up building something with this, please let me know. My DMs are open on Twitter. I'm in the Modal Slack. That's also where you can go to ask any questions if you run into troubles along the way. So please do hit me up there if you build something cool on Modal or if you need any help. Happy building. Take care.